Hi, this is Ujjwal Gandhi from spatialthoughts.com. This is another Python tutorial on using GeoPandas to do spatial queries. The idea here is you have two spatial layers and you wanted to find features from one layer that are within a certain distance from another layer. And to do this, we need to apply some spatial analysis technique, which I'll be showing in this tutorial. I'll also be showing some data cleaning and visualization technique that you'll find helpful. So with that, let's get started. We are using Colab for this tutorial. You'll find the link to the complete notebook in the description, which you can use and run the code yourself. The example we are taking is that we have a location of all the metro stations in the city of Melbourne, and we want to find all the bars and pubs that are within 500 meters of that metro station. So we'll take a layer of all the bars and pubs, and then we'll filter it down to all those establishments which are within 500 meters. The idea is maybe you are going out celebrating and you want to drink and you don't want to drive back. So you'll say, I'll take metro and I want to find pubs that are within walking distance, maybe 500 meters from a metro station. So let's see how to do this in GeoPandas. Here we have, we'll run some cells to do the setup, get the data, and then I'll code live and explain each step. So first we need to start running the cell. As you first time you run it, you're going to get connected to a virtual machine, and it's going to take a couple of minutes for the machine to get activated, and then we need to install GeoPandas. Colab comes pre-installed with many libraries such as Pandas, but it doesn't come pre-installed with GeoPandas. So we run the cell, which is just going to go and install the required libraries for using GeoPandas. Once this finishes, we're going to import the required packages. We are using Pandas and GeoPandas. We import Pandas as PD by convention, and we also import GeoPandas as GPT by convention. Since we'll also be doing some visualization, importing matplotlib, pyplot submodule, PLT. And again, these are just the variable names that you use for convention. You can use anything, but I recommend you stick to convention so your code is more readable. Even if you copy paste code from somewhere, it'll just work without you having to change the variable names. I like to keep my data organized, so I'm creating a subfolder called data in my current directory and another folder called output where we'll save all the output. And then we'll run this cell to download the data from my GitHub repository onto the Colab machine. So once it's done, you'll see in the folder here that we have this data folder containing these two different layers. One is a CSV file containing all the locations of bars and pubs as text. And then we have a zip file containing all location of metro stations. So now let's start working on this. First, we'll take this CSV file, read it using Pandas, and then we'll convert it into a geodata frame. So let's just say CSV file. I'll take the name of the CSV file here, and we'll create a path. I like to always construct path using os.path.join. This way, your path separator is correct depending on the platform that you're using, whether you're running this on Windows, Mac, or Linux. And now once we have this, we'll just create a data frame, and we'll use Pandas to read the CSV file. And let's just see the data frame. So you can see there are about 3,000 rows in this CSV file. We have different locations. The most important ones are the X and Y coordinate. This is what we'll use to create a spatial points layer that we'll use for our data set. This data is obtained from the text records in the City of Melbourne's open data site. So this is, not really suitable for spatial analysis. There are multiple records for each bar and pub. establishment they have. Since it's a text database, they have one record for every year, and we can check that. So let's just look at this data frame. And there is a property ID. So if we just sort this data frame by property ID, so sort values is the pandas function to sort the data frame by a column, and we'll just sort by this ID called property ID. Let's just see. So now you'll see that there are multiple records for each property, and they are for different years. Each year that they were assessed by the tax office. So we just want to keep one. We don't want multiple duplicate records. So we can use the pandas functions to call drop duplicates, to drop duplicate values of this. So we'll use the drop duplicates function. And if we do this, then only the rows which are complete duplicates will be dropped. But we just want to say, consider only the property ID column as the column to check for duplicates. So we'll have to specify the subset here. I will say just check. You can give a list of columns that you'll consider. We'll just say, just take the subset ID and drop those. So now you can see we got only 308 rows. So these are all the unique row IDs that will has a unique property ID. So this one is now suitable for our analysis. When you're dropping duplicates, you have multiple options on which record you want to keep. Say there are 10 duplicate records, which one you want to keep. By default, there's a parameter called keep. It uses first. So whatever first record it finds, it's going to keep that for as a record. Is going to drop all the subsequent ones. There are options you can do last. You can also keep it first. That means any record that is duplicate, just remove it completely. So here first is okay for our case. And we'll just say this is going to be our data frame. So I'm just going to overwrite the variable and say now my bars pub data frame is this one with no duplicates. So we are now ready to create a geodata frame. Geodata frame is nothing but a pandas data frame with a geometry column and a CRS. So let's create this first geometry column. How do we create a geometry column? We can use the GeoPandas helper function, points from XY. You know that we have the X and Y coordinate of each location. We can turn that into a point geometry. So we'll take this and we'll say bars pubs df of X coordinate. So this is our X coordinate, and then we need to give a Y coordinate. Let's check the geometry. You can see now you get a point geometry for each point. So we have a geometry column. We can now assign that to create a geodata frame. So we're going to create bars pubs geodata frame. So we're going to take use GeoPandas function geodata frame. We're going to take our original bars pubs data frame. We're going to assign a CRS. We know the coordinates are in lat long, so we're going to assign it the CRS EPSG 4326, and we're going to assign it the geometry column, which is the one we just created. Let's check if this worked. Okay, so now we have a geodata frame. And the difference is now we have a point geometry as a new geometry column. Okay, so let's visualize this. To visualize this, I prefer a certain template. We're going to use matplotlib. So we'll first create a figure, set its size, and now we have the axis where we can plot this data frame. So we'll take the bars pubs GDF, and we're going to plot it on this axis, and we're going to say plot.show. Okay, so these are the different bars and pubs that are present in the city of Melbourne. We can make it set some options. So let's turn them into a red color. We'll also set the marker. Instead of a round, we can set it to cross. And then we'll just set the transparency a bit to be 50%. Let's see. Okay, so these are the locations of the pubs. Now let's read in the metro stations and we'll overlay them on top and see how they are related with each other, and then we'll do our analysis. So we have the metro station zip file. We're going to store them into this variable. We'll just say the metro stations accessibility. This is the name of our zip file. We'll construct the zip path. And if your zip file contains just one shapefile, GeoPandas are able to read that directly. So we'll just say metro stations GDF equal to gpd.read file zip path. Let's check that. So we have about 219 metro stations in the city of Melbourne, and it's already a geodata frame, so we can now go and visualize that. So I'm going to take the previous visualization block code and say we're going to overlay the metro station GDF on top. We'll plot it on the same axis, and we'll make it blue color. We'll make it fully opaque and use the round markers. So you can see now we have the whole metro station network, and the bars and pubs are in the CBD, so it's a smaller region. So this works, but we can't see the bars and pubs clearly. So it will be helpful to just zoom our visualization over the region where there is the bars and pubs. So we can take the bars and pubs, GDF, and use the attribute total bounds, which will give you the bounding box of the data frame, which is the bars and pubs. And we'll use this to set the bounds of our visualization. So the total bounds are in this format. And we're going to take this and we're going to say for our axis, we're going to set X limit to be min X and max X. And same way, we're going to set our Y limit to be the limit of the bounds of the bars and pubs data frame. Let's see. So now you can see we are zoomed in only to the CBD region, and we can now see the blue dots, which are the metro stations, and the pubs, which are in the red. And now our analysis requires us to find all the red crosses that are within 500 meters of a blue dot. That's what we need to do now. The technique we're going to use is we're going to buffer the metro station points, and then we're going to intersect it with the bars and pubs and find which are the bars and pubs that intersect with buffer. So to do any kind of buffer analysis, we can't work in the CRS 4326 because the units of that CRS is in degrees, and we can't measure distances in degrees. So we need to reproject those to projected CRS. The choice will depend on the region that you're working on. You can use an UTM projection for that region, or if there's a appropriate national or regional projection that you want to use, you can use this. For Australia, we're going to use the GDA 2020 CRS, and Melbourne falls in that zone 55. So the CRS that we get, the IPSG code is 7855. And once we reproject, we're going to get the unit of measurement will be meters. So first, let's reproject. So we'll take our metro stations, GDF, and call 2 CRS. And we're going to do IPSG 7855. Okay, let's see what happens when we do this. You can see now the point coordinates are no longer in lat long. They are in XY coordinates in this GDA 2020 CRS. And we're going to just save it to another data frame. We'll name it Reprojecting. And we're going to do the same thing with the bars and pubs. So we've reprojected both of our layers, and now we are ready to do the analysis. So first we're going to take our metro stations and we're going to buffer it. So we have the buffer function in GeoPandas, and we're going to specify the radius. And here we're going to just say 500 meters. Okay, so this is going to give you a polygon geometry, which is each point is buffered by 500 meters. Okay, so let us create this buffer, save it into this buffer geometry, and we'll just say metro stations GDF reprojected. We're going to say override the geometry of this layer with the buffer geometry. Okay, let's visualize the buffers. So I'm going to take our visualization block and let's visualize the buffers now. And we're going to just say face color none. This means we're going to not fill those, and we're going to make the edge color is blue. So we're going to have a blue outline and transparent fill. We don't mark it anymore. And this has to be also the reprojected one. Otherwise, they are not in the same CRS. And this has to be also changed. All right. So now you can see the metro stations points are now replaced with the polygons representing the buffer region. And now if we just intersected these two layers, we're going to find all the bars and pubs that are within that circle of 500 meters, and we'll get an answer. There's one more problem though. You can see those circles are overlapping. So now if we intersect them, each point will intersect with multiple circles. You're going to get duplicate points in your output. You'll have to deduplicate them again. There's also a very common analysis where you want to do buffers, but you want to do a dissolved buffer, so that when you will get just a single polygon representing all the region which is within 500 meters of a metro station. All right, so now let's dissolve all the buffers. The way to do this in GeoPandas is we need to have a unique column where all the values are the same for all the features that we want to dissolve. Since we want to dissolve all the features, we need a column where all the features have the same value for that field. We don't have such a field in our data frame, so let's just create one. We're going to create a field called dissolve field. So I'm going to take the metro station reprojected. We're just going to add a new field, dissolve field, and assign value 1. It could be anything. Just a constant value is fine. If you already have a column where all the features that you want to merge have the same value, you can just use that instead. And now we can just say dot dissolve, and it's got a by parameter. We'll just say by this new field that we just created. And we're just going to save it into a dissolved GDF. Right. After fixing the typo, it worked. So now we're going to update our visualization to see can we visualize the dissolved buffers. So we'll replace this with the dissolved buffers. And you can see now all the polygons that were overlapping, they are now merged, and we have a single polygon, which is all the places which are within 500 meters of a metro station in Melbourne. And all that is left is to now do a spatial join and find all the bars and pubs that are intersecting with the buffer zone. So we'll do gpd.sjoin, which is the function for doing spatial join. We'll join the bars, pubs, GDF, reprojected with dissolved buffers. One thing to remember is both the data frames have to be in the same CRS. So we are using both the reprojected CRS here. We're going to do how, which is going to do inner join, and the predicate is going to be within. So you can now see we have about 204 points that have been selected, which are which are within the buffer zone that we had indicated. And we can save it to another variable. I'm going to save it to a data frame named selected. And we can add that to our visualization just to verify that we got the results correct. So we're going to take this and overlay one more layer on this plot. We'll take our selected. I'm going to plot this, but this time we're going to put it in color yellow. So these are the selected ones. And we're going to keep the other parameters same as the other bars and pubs. And if everything went right, these yellow dots should be all within the blue circles. So you can see now these are the selected bars and pubs, which are within the 500 meters of a metro station. And we are done with our analysis. The last thing that is left to do is to save our output. So let's just create an output file. Just say we'll save all these layers into a geo package called spatial query.geopackage. I like geopackage because it can store multiple data layers in a single file, which is a great format for data storage and data management. And it's a lossless format. There's no restriction on what's the field name length or how much data you can store in each field. So I really like geopackage as the format for storing data. We'll construct the output path. We already have a folder called output folder. And we're going to put the file there. And then we're going to take each of our data frames and write it there. So first we're going to take our bars, pubs, GDF, and we're going to say to file. We're going to write it to the file name is our output geo package. And since it's one file containing multiple layers, we need to give the name of the layer. So bars and pubs, and we'll repeat the same thing 3 times for each of those layers that we want to save. So the second we want to save is the metro stations GDF reprojected. Yeah, I want to save not the original one, but the reprojected one here. And we're going to name this one metro stations. And finally, the selected locations. And this will be the selected. Let's run this. And we should have a new geo package in our output folder. Let's just download it locally, and we can check the results in QGIS to ensure we got everything correct. So here I'm in QGIS. We have this geo package. If I expand this, you can see there are 3 layers that are contained inside. We have the bars and pubs, we have the metro stations, and then we have the selected locations. And you can see the selected locations are all within the metro stations. Right. So we got our analysis, which looks correct. It's also in the correct CRS. QGIS is recognizing that. So we started with a CSV file and a shape file, and we reprojected both the layers, created a spatial layer, did buffer and dissolve, and then intersected both these layers to find all the bars and pubs within 500 meters of a metro station. Hope you learned some new tricks, and now you know how to do spatial queries in GeoPandas. Stay tuned for more Python tutorials like this. Thank you.